score test for goodness of fit, and previously we had posted on all the videos of test like large sample test, then T test, then F test. Okay, those are all important, and you can find this link easily on the YouTube channel. Then today in this lecture, we are going to discuss a very important distribution, and it's and the test based on it. That is the chi-square distribution. Okay, so it is written like this. So spelling is right CHI, but it is written as or pronounced as chi-squared. Okay, so let's move further. What is the objective of this lecture? So main objectives are to understand what is a chi-square distribution, because you are studying the test based on it, then you should be having a little knowledge of chi-square distribution and its applications. Okay. Then next thing, I will explain you the chi-square test for goodness of it. Okay. Then numerical examples on it. Now let's understand what is chi-square. So chi-square distribution is a continuous probability distribution that is used in many hypothesis testing. The shape of the chi-square distribution is determined by the parameter k. K is what? Degrees of freedom. Okay. The graph below. Okay. So graph is not available. I will show you later on. No negative values. It do not take negative values. So the graph is like this. So it is a kind of skewed graph. Okay. Chi-square distribution are useful for hypothesis testing because of their close relationship to the standard normal distribution. Okay. The standard normal distribution, which is a normal distribution with mean 0 and variance 1, is central to many important statistical tests and theories. Okay. So we just wanted a short distribution. So it's a continuous distribution that you have to understand, and then it has parameter degrees of freedom n. Okay. Sorry. Am I clearly audible?
Yes, sir.
Now, thank you. Now, applications of chi-square distribution. So, what are the applications? The test we are implementing or the test we are using are nothing but the applications. So, population variances. Then, to test if the hypothetical values of a population variance is sigma square, okay, is equals to sigma naught square. This is not properly typed. So, it is equals to given value of वेरिएंस. जैसे कि हमने ये डिफाइन किया था ना पॉपुलेशन मीन टेस्ट दैट द एवरेज वैल्यू इज 35. ओके, सो गिवन वैल्यू स्पेसिफाइड वैल्यू, सो whether it is equal to population variance is equal to the specified value of population variance, that is sigma naught square. Okay, so that is not properly typed there. Then test for goodness of fit, which is now we are going to understand, and test for independence of attributes. So these two are in the syllabus. Then these are some more applications, so which are not in syllabus. So we'll move ahead. So now this is the test number 14. Okay, so chi-square test for goodness of fit. So what is this test about? So this test is totally about means you are given a particular data. Okay, you are given a particular data, and then you have to test it whether the whether the data you obtain is according to the theoretical data. So here we use two terms, remember. So one is called as, there are two kind of frequency we use here. I write it here. Two kind of frequency we use here. One is observed frequency. One is called as the observed frequency OI. And then another frequency is expected frequency. It is called as expected frequency. Okay, so this entire test is based on these two values, observed frequency and expected frequency. If you understand this, you understand the you will definitely understand the remaining part. Okay, now what this test do? So see, I give you a practical example. Okay, and then I will move ahead. Suppose a shopkeeper has some electronic, suppose somebody has electronic shop, TV. He sells the TV just like Vijay sells. Okay, I'm talking about only TV, television set. Suppose a shopkeeper sells the television set. So every day he maintains a record, means Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, and let it be Sunday also. So all the 7 days he maintains how many TV is being sold. Okay. So number of units sold, number of units TV units sold. Okay. So suppose he got get some values like 17, 18, 15, 16, 19, 20. So Saturday and Sunday may be having more demand, right? So 22 because rush. Okay, and people are having holidays, right? So this is the data. So what is the observed value here? What is the observed value here? So observed values are these are. So Monday, this is the first observed value O1. Second means observed number of TV sold on Monday 1, Tuesday 2, Wednesday 15, isn't it? So in this way, these are the observed frequencies, means actual how much sale was there each day. Okay, so that is the observed value. Now we compare that. We are making a statement. Somebody is making a statement that TV are uniformly sold. Television sets are uniformly sold throughout the week. Throughout the week. Okay. So now when I say uniformly, then there must be equal number of sale, isn't it? So what I do, I simply take the total frequency and divide equally. Okay. So I am calling it observed frequency first one, which is original, and this is expected. So I simply get the total of all the TV sets. Okay, so 17 plus 18 plus 15 plus 16 plus 19 plus 20 plus 22. Okay, so total are 127. I'm roughly taken this, randomly taken these values. Okay, so 127 TV sets are sold in the throughout the week. Okay, so now I divide it by 7 because there are 7 days in a week. So on an average, so what I am observing, so according to my statement, I'm making a statement that is a hypothesis. TVs are uniformly sold throughout the week. So accordingly, what I do, I equally divide the number of sales. Means uniformly. If I said uniformly, then I have to do it uniformly. Okay. So 18.11, 18.14. This is the average. 18.14, 18.14, and so on. All the values will be 18.14. Okay, so now these frequencies which I get, these are called as the expected frequencies, EI. Okay, and now this test, what exactly doing? He is studying, he is analyzing the different discrepancies. Discrepancies means difference. He is analyzing or studying the discrepancies, whether डिस्क्रिमिनेंसेस बिटवीन द ऑब्जर्व वैल्यू एंड द एक्सपेक्टेड वैल्यू, यानी कि ऑब्जर्व वैल्यू और एक्सपेक्टेड वैल्यू में क्या डिफरेंस है उसको स्टडी करके ये बताएगा कि जो डेटा हमको मिला है वो फिट है, यानी कि वो प्रॉपर है कि नहीं है. द फिट इज गुड का मतलब क्या होता है? फिट इज गुड का मतलब ये होता है कि द डेटा वी हैव ऑब्टेन्ड, द डेटा वी हैव गॉट फ्रॉम द सर्वे इज ओके, प्रॉपर. ओके, और फिट इज नॉट गुड का मतलब क्या है? द डेटा वी हैव गॉट इज नॉट अकॉर्डिंग टू द स्टेटमेंट वी आर मेकिंग. हमने बोला कि यूनिफॉर्मली सेल्स हो रहा है, बट ये डेटा उसको सपोर्ट नहीं कर रहा है. Are you getting my point? So this is called as the fit is not good. The fit is good or fit is not good. हम bad नहीं लिखते हैं वहाँ पे. The fit is bad. We don't write that. Okay, this is wrong way. Either fit is good or the fit is not good. Okay, did you understand? So this chi-square test for goodness of fit is all about the observed frequency and the expected frequency and their discrepancy. Okay, so I come to the next slide. Here there is a blank sheet because I could explain you the formula. So what is the hypothesis? So the example which I have explained you, now I explain you so that you understand this test. So what will be our hypothesis here? The cells, TV cells is uniformly distributed. Okay, TV cells are uniformly distributed over the week or throughout the week. Over the week. इसका मतलब क्या हुआ? The fit is good. Remember, okay? It means the fit is good. There should not be any confusion in your mind. Okay? And I don't like confusion in any of my students. Against it, what is the statement? The TV cells are not uniformly distributed. Uniformly distributed. I don't write the entire statement now. That is, the fit is not good. Okay, so I hope you understand this one. Now, the formula which I use here, test statistic. Okay, test statistic under H0. Okay. So the test statistic is, so calculated value of chi-square. Okay, it is, what is the formula there? Say summation OI minus EI whole square divided by expected value. Okay, so it is summation OI means observed value minus difference of square of the difference of observed frequency and expected frequency upon EI. Okay, this follows chi-square distribution with n minus 1 degrees of freedom. Okay, so what is the degrees of freedom? It is one value less, one observation less than the total observations. Okay, for one-way data. For two-way, it will be subtract 2. Okay, so but note one thing here, that total observed frequency and total expected frequency must be total frequency, because it is after all frequency, and frequency must be equal whether it is observed or expected. Okay, that you have to take care. For calculation purpose, we can simplify this, and after simplification you get OI square upon EI minus total frequency. Okay, if somebody wants to show, somebody wants to see how this is coming, then just quickly I can show you how it is coming. Then I will erase it. So OI minus EI whole square upon EI. Okay, so if you solve this just like A minus B whole square, so OI square minus twice OI EI, okay, plus EI square upon EI. Okay, so if you do all these things, so OI square upon EI minus twice summation OI, because EI will get cancelled here in the middle term, then plus summation now EI square upon EI means it is EI only, right? Okay, so now just simple solving, summation OI square upon EI minus twice. What is summation OI and summation EI? That is nothing but n. So I have already written here. You can check it. Okay. So So twice n minus twice n plus n, because summation y plus summation ei both are same values. Okay, so finally you get the formula I have mentioned there. Okay, summation y square upon ei minus n. So there should not be any doubt in your mind. Okay, so how this came. So throughout the numerical, we are going to use this one, right? We are going to use this formula. You can also use this one, no problem. So whichever is suitable to you, you can follow it. Both the way you are getting the same answer. So I gave you the all background about this. So this test is particularly used whether the given data or observed values are proper or not. Okay, according to the distribution mentioned there in that problem. So now we'll come and solve the numericals based on it. So this is the very first example, and everybody has to understand it properly. I take this problem on the Excel so that we can comfortably solve. So I take it on Excel. Okay, just a minute. I take the simply this values data I take here. Okay, so I got the data. I don't want anything else then. Okay, so just calculation purpose, I'm using the Excel. It is fast, reliable, and easy. Okay, so read the question now. Okay, so in a set of random numbers, the digits 0, 1 to 9 were found to have the following frequencies. Okay, so test whether they are significantly different from those expected on the hypothesis of uniform distribution. So indirectly, what you are asked to do or asked to test whether all the digits are uniformly distributed or not. यानी कि 0 to 9 सभी एक जैसे आने चाहिए, यानी कि इक्वल नंबर ऑफ आने चाहिए. ठीक है, तो नो प्रॉब्लम. फर्स्ट वी मेंशन हियर हाइपोथेसिस and then we shift to the Excel. Okay, so what you have to test here, before testing, let us define, very important because this test is based on observed frequency and expected frequency. So OI means, define it, observed frequency. Okay, and what is EI? It is expected frequency. That must be clear in your mind. And what you have to test now, so our hypothesis is, now hypothesis may change according to the question, right? So here it is exponential distribution, so we'll apply here it is uniform distribution, so we will make all the frequencies equal later on. Okay, so H naught is the digits. What is the null hypothesis? The digits 0 to 9 are uniformly distributed. Uniformly distributed. Okay. Against it, what is the statement? H1 will say the digits, just opposite of it, the digits 0 to 9 are not uniformly distributed. Okay. So did you all understand? Somebody say loudly and tell me. Are you understanding?
Yes, sir.
Okay. So this is, now we'll write the next thing, test statistic. Steps are fixed. They are never changing. Slight changes. So under H naught. Now under H naught, what do you mean by that? Again, I'm telling you, assuming H0 to be true, you always proceed with this H0, assuming H0 to be true, because if you don't assume it, at some end you have to assume something, either you have to accept it as a true or accept it as a false, then only you can proceed, because these are all what statements, these are all what assumptions. So test statistic under H0 means assuming H0 to be true. So what is the formula? Calculated value of chi-square. Now I will use the formula which is recently. So y square upon ei summation I varying from n minus n. Okay. So this will follow chi-square distribution with n minus 1 degrees of freedom. Okay. So we'll need a chi-square table also. So that will open. Now this is the background we have created now. Now we'll do the actual calculation. Okay. So what calculations we need first of all? Before that we have to do one important task. हमने क्या कहा अंडर एच नॉट है ना, तो अंडर एच नॉट क्या कह रहा है यूनिफॉर्म डिस्ट्रीब्यूशन। तो अभी हमको कुछ कैलकुलेशन करना है। हियर टोटल फ्रीक्वेंसी क्या होगा समेशन ओआई या फिर समेशन ईएल। ओके, दोनों का टोटल एक ही आना चाहिए। सो हाउ मेनी नंबर्स आर देयर यू हैव टू काउंट इट। ओके, तो ये कैलकुलेशन जो है मैं एक्सेल पे ले लेता हूँ। सो दीज आर द नंबर्स। So I type these numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the digits are taken. Are you all able to see? Okay, I mentioned the frequency. So this is nothing but the observed frequency OI, and I will write afterwards EI. We will need this one, right? And these are nothing but digits. We have to prepare this table. Okay. So now observed values are given here 43, 32, 38, 27, 38, 52, 36, 31, 39, and 24. Okay. Something is missing. 43, 32, 38. Okay, here it is. Okay, here 52 and here. So when you say that uniformly distribution, so under H0, this is very important and note down somewhere. So what is the total frequency? First of all, get the total frequency because we need it. So here you get total 360. Where the total frequency? It is 360. Where? Okay, total digits, total observed total frequency is 360. Okay, so now we are in a position to solve this. Now under H0, what you are assuming? Uniform. Okay, you are assuming that uniform distribution, right? यानी कि सारे डिजिट्स इक्वली डिस्ट्रीब्यूट होने चाहिए। तो अभी एक्सपेक्टेड फ्रीक्वेंसी क्या होने चाहिए? टोटल फ्रीक्वेंसी अपॉन नंबर ऑफ डिजिट्स कितने हैं? 10. आर यू अंडरस्टैंडिंग माय पॉइंट?
यस सर।
तो यूनिफॉर्म डिस्ट्रीब्यूशन अंडर एच नॉट हम क्या कंसीडर कर रहे हैं, क्या बोल रहे हैं हम? यूनिफॉर्म डिस्ट्रीब्यूशन यूनिफॉर्मली डिस्ट्रीब्यूट होना चाहिए, यानी कि हर डिजिट इक्वली रिपीट होना चाहिए, इक्वली आना चाहिए। तो इसलिए हम नंबर ऑफ डिजिट्स कितने? 10, 0 to 9, 10। तो टोटल फ्रीक्वेंसी को हम डिवाइड करेंगे। सो 360 डिवाइडेड बाय 10। So every number must be, every digit should appear 36 according to the hypothesis H0. Okay, so that's why we write here 36. So these are the expected frequencies. These are the expected frequencies. So after doing that, we see the formula. What is required there in the formula? Summation y square upon ei. So I get that value there. Summation y square upon ei. So very easy calculation. I do it quickly. Y square, observed value का square कर दो. But doing this, make use of brackets. Sometimes it may create some problem if you don't follow this. So now this is a y square divided by ei. This is the ei. Do this. Okay. So now drag this. So you want the total summation y square upon ei, right? So just get it, auto sum, and you will get this. So this is 376.33. So this is the summation y square upon ei. So now remember this, both the values. Will come back to this slide. So what is that value? 376.33. Okay. So I quickly mention over here. So in that formula, now using that formula, what we get now, total frequency is 360, right? And summation y square upon ei, this total is 3. What is that value? 376.33. 376.33. Okay. So now test statistic. What was our test statistic? Our test statistic under H0 was, what was that? Calculated value of chi-square is equals to summation y square upon ei, I varying from 1 to n. Now here there are 10 digits, so I varying from 1 to 10. Okay, so minus n. So now put the values here. So put the values here. So summation, this total you have already find out here. It is 376.33 minus, what is the total frequency? 360. So what is the calculated value of chi-square? Now very easy. Now calculated value of chi-square is what? How much? So it is 16.33, right? So here is the calculated value, 16.33. So this is one part we have completed. Now we have to get the value from table. Okay, table value. Okay, to get the table value, you need two things. First, degrees of freedom. So how much degrees of freedom are there? How many numbers are there? There are 10 digits, right? 0 to 9. So 10 minus 1. So it is 9. And alpha, let me check whether it is mentioned or not. So alpha is not mentioned. So by default, it will be 5%. Okay, means 0.05. Now I will open a statistical table there, which is already with you. So in that you have to go to the chi-square. It is the third table, table number 3. So this is the chi-square table. Okay. So now in the very first column, you check the degrees of freedom. Our degrees of freedom is 9. Okay. And what is the level of significance? Now you go on searching here. Now here is the 5%. Okay, here. This is the 5% and this is the 9. Okay. You see the intersection value. So it is how much? It is 16.919. Okay. Okay. 16.919 is the table value. So calculated value. So we also call it as a, this is the square. Okay, I forgot it. So this is the table value. So how we write? This is the critical value. This is also called as the critical value. So this is 9 and 0.05. So what are the values? 16.919. Let's check once again. 16.919. So what's happening here? So this is the table value. You have to compare both. So comparing, again the same criteria. Comparing, we get what you get here. We observe chi-square calculated value is less than the chi-square critical value or table value. So what is our decision? Our decision is to accept H naught. Our decision is to accept H naught. Okay. So when we say H naught, then we are accepting that, we are proving that the digits 0 to 9 are uniformly distributed. Okay. Digits are uniformly distributed at 5% level of significance. So just write this. So it does mean that, it does mean this. So can you write the conclusion? So the conclusion is the digits are, did you all understand? Okay. Uniformly distributed at 5% level of significance. Okay. May not be, it will be the same case for other level of significance. ये बाकी level of significance पे accept भी हो सकता है, reject भी हो सकता है. Okay. So just close your mind, close your eyes and revise the process I have discussed to you. Okay. And we'll go to the next problem. Okay. So now, hope you understand this problem. This is very important problem. Means this kind of problem. In fact, the overall test is very important. Now, we'll solve another problem. So example number 2. Okay. This is a little bit different kind of sum. So in the exam, either earlier one type and this type. So any two type of example can be there if it is asked. Okay. And as I said, it is really important. So now here a different kind of data is given and it is a question of goodness of it. Now let's read the question. In experiment of P breeding, means P means you call it Marathi Watana. Okay, Hirve Watana. No. Okay. So in experiment of P breeding, Mendel got the following. Mendel, what's the Mendel? You know it? In 12th, got the following frequencies of seeds. Okay, so 315 round and yellow, 101 wrinkled and yellow, then 108 round and green, and 32 wrinkled and green. Okay, so theory predicts that the frequency should be in the proportion. We have to check this one. Okay, 9:3:3:1. Examine the correspondence between the theory and the experiment. थ्योरी यानी कि क्या कहता है ये 9:3:3:1 में होना चाहिए और हमको जो रिजल्ट मिला है यानी कि 315 101 108 और 32 ये रेशियो में है कि नहीं ये हमको चेक करना है ठीक है सो दिस इज द थ्योरी एंड दिस इज द एक्सपेरिमेंट सो यू हैव टू मैच दिस ओके तो लेट्स solve this example. So solution. So what you have to test? What is H naught? The frequencies are in the ratio. We do not write so much long statement, but required thing we'll write. The frequencies are in the ratio. The frequencies are in, I write even short, 9:3:3:1, okay? And against it, what is the statement? The frequencies are not in the ratio, not in the ratio 9:3:1. Because of space problem, I am shortening the statement. Okay, so if you, it is the same case, अगर frequencies 9:3:2, हम इसे fit is good भी कह सकते हैं. Okay, हम इसे fit is good भी कह सकते हैं. Okay, fit is good is a general statement. Okay, if it is not good is a general statement. So in that place, whatever is question in your whatever the statement in your question, that you have to write. Okay, so in this case we write this one. Okay, so let's move on. And first of all, mention the test statistic. Before test statistic, we summarize the data. Okay, now we can see there four categories we can see. Okay, we are observing there four categories, right? Okay, so which are the categories or types of seeds? So first one is round and yellow. So I write the initials round and yellow. Okay, so OI means observed frequency. Somewhere you mentioned here, OI means observed frequency. And what is EI? Expected frequency. Okay, so now OI means observed frequency, right? Okay. Now second category, now yellow, round and yellow, it is observed frequency is 315. Okay. Now wrinkled and yellow, wrinkled and yellow. So it is 101. Then round and green. This is third category. It is third category, round and green. So R and G. So this is 108. Okay. And next, final, wrinkled and green. So this is how much in numbers? 32. Okay. So total how many seats are there? How many seats are there? So that will be the total frequency. Okay. Then you know the formula now from the previous example. So let's take expected frequency. Okay. That is a very important question. I will tell you how to measure. I will come back to the next slide because I have to do some calculation. Okay. So test statistic. I mentioned here test statistic. I will come back to the previous slide. Okay. Under H naught, the formula is calculated value of chi-square is summation y square upon EI minus n. This follows, means you can put entire thing in a bracket. This follows chi-square with n minus, n minus 1 degrees of freedom. Okay. Okay. Now this is the formula, and under H naught now, under H naught. Now, what will be the expected frequency of round and yellow? Let's call it even. Let's call it even. Not I there, even. This is even. Let's call the expected frequency of wrinkle and yellow as E2. Okay. This is E3 and this is E4. Okay. Now let's do one thing. Now, well, how much part, total part it is? 9 plus 3 plus 3 plus 1 means how much? It is 16. Total parts are 16. So out of 16 part, the weightage of this round and yellow is 9. So what I do, first of all, get the total frequency. What is the total frequency? So better I create a table over here and do the calculation, isn't it? So, okay. So what I get, round and yellow, okay. Round and yellow, then round and yellow, this is a 315 in number, 315 in number. Then next, wrinkled and yellow, 101, wrinkled and yellow is 101. Then 108, round and green, round and green, it is how much? 108. And finally, wrinkled and green. So I'm taking this entire data here. So it is 32 in number, right? It is 32 in number. Okay. So this is the category of seeds, and this is the observed values. And now I want to get the expected frequency. Okay. So what is the proportion? It should be, ये किस proportion से रहना चाहिए? What is the proportion told to us? So all these values should be 9 is to 3 is to 9 is to 3 is to 3 is to 1. Okay, isn't it the same? Okay. So what I do, I know the total parts are 16, right? So iska total kar doge to 16. So out of 16, how much weightage is there? Oh, I just zoom it. Okay. So everybody can properly see these calculations. Okay. So this is the data. So it should be according to this. Okay. So out of 16, even is 9 out of 16, right? So be careful. जो ratio दिया है उसी ratio में लिख रहे हो. Out of 16, 9 parts are of this one. And just a minute. इसका total हमको पता करना है. What is the total value here? How many seats are there? There are 556 seats are there. There are 556 seats. Okay. So this is the total frequency. So 556 के 9/16 part जो है वो even होना चाहिए. Okay. So now we'll use the formula. So it is equal to this one, this total frequency. So expected value should be according to this theory. 9 total parts है 16 में से 9/16 पार्ट राउंड एंड येलो के होने चाहिए. तो वैल्यू कितना हो गया? 312.75, राइट? ओके. सो नाउ नेक्स्ट वन E2 शुड बी, यानी कि येलो एंड व्रिंकल एंड येलो का क्या प्रोपोर्शन, क्या नंबर होना चाहिए अकॉर्डिंग टू? सो 3 डिवाइडेड बाय 16, राइट? क्योंकि 3 parts out of 16 total parts into this total frequency. ये ओके. एंड सिमिलरली इसका भी सेम आएगा. इसका भी यहाँ पे, अच्छा ये फॉर्मूला का एरर है थोड़ा. ओके. This is only because of the formula error. You cannot copy paste or anywhere else. Okay. सो यहाँ पे भी 104.25 आएगा। क्यों? क्योंकि वो भी 3 पार्ट्स है। ओके, और लास्टली यहाँ पे क्या आएगा? इट इज 1 part out of 16 of this one into total frequency. तो ये कितना होगा? 34.75. दिस इज द 1 part out of 16. तो ये आपको करना है। इसके बाद अकॉर्डिंग टू द फॉर्मूला आपको क्या लगेगा? OI का स्क्वायर, ओके, डिवाइडेड बाय एक्सपेक्टेड वैल्यू। तो ये हम फॉर्मूला के हिसाब से फाइंड आउट करते हैं, बिकॉज देयर इज अ फॉर्मूला ओवर देयर, राइट? व्हाट इज द फॉर्मूला ऑफ chi square summation of y square upon EI, okay, minus n. This is the formula of chi square और द टेस्ट स्टैटिस्टिक। ओके, तो ये फार्मूला हम फाइंड आउट करके रख देते हैं। ठीक है, तो ये फार्मूला के हिसाब से वैल्यू भी फाइंड आउट कर लेते हैं। सो दिस इज y स्क्वायर, गिव ब्रैकेट, so to get the square I will just multiply again, yes, divided by expected value, so you get it, then drag it and get the total. Very easy. So this is what, this is your summation. This is the numerator, this is the summation you wanted. So this total is nothing but summation OI square upon EI. And what is this? This is total frequency. Okay, so now let's come back or do the calculation over here only. So under H0, what was the formula? What was the formula? Calculated value of chi square is equals to, now I have directly write this, summation OI square upon EI means 556.47. So other zero, so I don't mind it. So minus total frequency was 556. So how much the value it is? 0.47 is the calculated value. Okay, so I come to this slide. Did you all understand this? Yes or no?
Yes sir.
और यहाँ पे E1 E2 कैसे फाइंड आउट किया है? ये E1, ये E2, E3 एंड E4 ये कैसे मिला? जैसा आपको रेशियो दिया गया था 9:3:3:1, इसी रेशियो में फाइंड आउट किया गया है। तो E1 कैसे फाइंड आउट किया? 9/16 into n. E2 का वैल्यू कैसे मिला? 3/16 into n. Similarly, E3 means expected value of expected frequency of round and green. It is again 3/16 into n, and finally fourth expected value it is 1/16 into n. n is 556. तो इस तरीके से ये वैल्यूज मिला है। ओके, अब यहाँ पे कैलकुलेट वैल्यू कितना है? 0.47. विल कैरी हियर। सो आफ्टर डूइंग ऑल द कैलकुलेशन, तो हमको क्या मिला है? chi स्क्वायर कैलकुलेटेड वैल्यू कितना मिला है? 0.47. ये ऑलरेडी हमने देखा हुआ है। ठीक है, तो अभी टेबल वैल्यू, नेक्स्ट वन, एक बार कैलकुलेटेड वैल्यू मिल गया तो आपको टेबल वैल्यू देखना होता है। सो टेबल वैल्यू हम कैसे देखते हैं? फिर से आपको एक्सप्लेन करता हूँ। डिग्रीज ऑफ फ्रीडम यहाँ पे कितना है? n-1. n यानी कि क्या? हाउ मेनी कैटेगरीज देयर? कितनी कैटेगरी बताए थे आपको? राउंड एंड येलो, wrinkled एंड येलो, राउंड एंड ग्रीन एंड wrinkled and green. तो कितने कैटेगरीज हो गए? n is equals to 4, isn't it? Yes. So it is 4 category. So कितने डिग्रीज ऑफ फ्रीडम हो गया? 4-1 यानी कि 3. Okay, and is there any reference of alpha level of significance? No. So by default alpha should be taken 5%, means 0.05. So your table value, chi square table value, or in standard language you call it critical value, it is degrees of freedom and alpha percent level of significance. So standard way of writing is, it is 0.05. 3 means degrees of freedom. First value is degrees of freedom and next value is the alpha. Okay, so let's check the table. So it is 3 here, degrees of freedom is 3, and alpha is 0.05. So it is 7.815. Can you see that value? 7.815. Okay. So table value is 7.815. So let's call it 1. Let's call it 2. So comparing, we clearly observe that what's happening here, calculated value chi-square calculated value is far less than the calculated table value. So in that case, we accept H0. Okay. So finally, we come to conclusion. So what's happening here? It's a good practice to write the conclusion in terms of question it is asked. Examining the correspondence between the theory and experiment. So what do you want to say? ये कंक्लूजन अच्छे से लिखना चाहिए, इसलिए हम यहाँ पे डिफाइन करते हैं. यहाँ पे डिफाइन कर दिया तो बाद में कंक्लूजन में क्या लिखना है वो आपका क्लियर हो जाता है. तो H0 क्या कहेगा? The frequencies are in the ratio that one. Okay, so ज्यादा लिखने की जरूरत नहीं है. The frequencies are in the ratio 9:3:3:1 at 5% level of significance. Don't forget to write the level of significance. Okay, so this was the question we have solved. और ये दो टाइप में से क्वेश्चन आपको आ सकता है. All of you understand? If blow your thumbs if you understand it. Okay, and thank you. And now these are the examples for your practice. So what you do, you just quickly take the screenshot. Okay. So thank you very much for this lecture. One more test is remaining. I will explain it shortly. Thank you. We'll come back.